Okay, almost done. We were looking at the side angle side similarity, and we said to make sure that the two triangles are in fact similar, we have to test for for proportionality to make sure they actually are proportional to each other. We did that for the first set up here, that the angle was in between the two sides, and 8 over 6 is equal to 20 over 15. So they were proportional, which means that the two triangles are similar. I want to test this bottom one, but I want to talk about what to do here. There's more than one way that you can do this problem, but what I like to do with these overlapping triangles, I like to redraw them as separate triangles. And the only reason I like to redraw them as separate triangles is because it's easier to see which sides match up, which sides are corresponding. You do not have to redraw them, but I do recommend showing that as a teacher. If you're doing anything with overlapping figures that overlap on top of each other, draw them separately. A lot of students struggle with seeing the different triangles and finding those relationships. And if you can draw them separately, it makes it a little bit easier to find those relationships. And since proportional problems are all about relationships, seeing the relationship is very helpful. So I'm going to fill in the information that I know. So there we go. That's the information that's given to me here. They do share an angle. Angle A is the same on both triangles. So we do have the angle being congruent in between the two sides. So side angle side, side angle side. If they were exactly the same numbers, 25, 25, 21, 21, we'd have side angle side congruence, and they'd be the exact same size triangle. They're definitely not the same size, so we need to check to see if they form a proportion to each other. So I should be able to compare 15 and 25, 12 and 21, and see the same relationship. Again, I could divide and make them into decimals. You could cross multiply. I'll cross multiply this time just to be different, just to show a different way. So I'm going to do 15 times 21, and I get 315. And then I'm going to do 12 times 25, 300. These are not the same, which means these are not proportional. These are not similar to each other. Didn't work. They're not similar. We would hope that they were, but they're not. So that's how you can test to see, are they in fact similar, and how do we know? Side angle side similarity, side similarity. Nope, don't want to do that. Just do this. Side angle side similarity, side similarity, and angle similarity. So the fewer, and you have this printout, I will print it out as well. So if you don't have your own copier or printer, you can have a copy of it, but you can use that for notes. All right, what I'd like you to do now is I'm going to work through one problem with you of solving using similar triangles, and then I'm going to ask you to do a couple on your own, and that'll be it. Okay, so I'm going to do this problem. A lot of standardized tests and textbook tests really like shadows. Shadows show up all the time. The building has a shadow. The tree has a shadow. The pole has a shadow. The person has a shadow. The kangaroo has a shadow. They love shadow problems. So we're going to start with a shadow problem. We've got this sunny day. Tall tree casts a shadow of 40 meters. And I'm drawing a poor sketch of the same thing on my paper as I'm talking. So we've got this tree with a 40-meter shadow, and we've got a meter stick, a 1 meter stick that casts a shadow that's 2.5 meters. One thing to be careful of, I'm not going to do this to you, but one thing to be careful of is if these labels didn't match, if it said that one casts a 40-meter tall tree and the other one has a 3-foot tall stick, or a 2.5-foot shadow, if the labels don't match, then you have to make the labels match. So the only way to compare things using a proportion to compare is if we're talking about the same thing, if the labels are the same. I'm not going to do that. I'm not going to, on the test, change the labels on you because I don't want, well, because I'm not going to. But that does show up. Be careful of labels. These labels do match, meters to meters, meters, and then our question is, how tall is the tree? How many meters tall is the tree? So here we go. We have two triangles, and it told us, well, it didn't tell us, I guess, but in this situation, these are right triangles, and due to the angle of the sun being the exact same, we do have angle-angle similarity, so they are similar. And that's how we can tell, is by the angle of the sun is at the same time of day. Regardless, two triangles are similar. We can set up a proportion. If we want to figure out how tall the tree is, we can compare shadow to shadow, height to height. So I'm going to write that out, and I guess I'll go from left to right again because that's what I've been doing. So I'm going to go shadow to shadow, height to height. And we'll solve this in a second. There is another relationship that you could make. You could also do height to shadow, height to shadow. As long as you're consistent with the way you make your relationship, it's the exact same thing. Notice here I'm going to do 40 times 1 and 2.5 times x when I cross multiply. 40 times 1, 2.5 times x. It's the same proportion. So the relationship is what's important, and being consistent with the way you make your relationships is important. All right, 40 times 1, I can do that in my head. That's 40. And if I do 40 divided by 2.5 to solve for x, I get that there is a 16-meter tree. And that feels right. The tree should be bigger than the meter stick, a lot bigger than the meter stick. Most trees are anyways. So 16 meters, yeah, that's a big tree. But that's a reasonable height for a tree. So there we go. That's how we can set up these proportions using similar figures, similar triangles, to solve for a missing piece. So what I'm going to ask you to do is I'm going to ask you to, there we go, try this problem here. We already talked about what you can do if you have overlapping triangles. So pause it and give this problem a try. I'm assuming you paused it. I'm assuming you tried it on your own. Please do. Don't just wait for me to do it. That isn't helpful. Try it on your own, see what you get, and then come back to it. I'm also wasting time because I'm drawing the picture on my screen. We were told at the top that these two triangles are similar to each other. It was given to us. We didn't have to decide if they were or not. Because we know they're similar, because they told us they were similar, we should be able to set up a proportion. In fact, we can. I shouldn't even say we should. We can set up a proportion between the different sides. I'm going to redraw these triangles. So I'm going to draw the small triangle, and I'm going to draw the big triangle. You do not have to do this, but I'm going to, because I find it helpful for me. Let's see, this side here is 90. I find it helpful for me to organize all the numbers. There's lots of numbers and lots of lines on that picture. So which number goes where, and then I find it easier to set up my relationships, to set up the proportion. I'm wondering about this side. That's my question. And the corresponding side on the large triangle is 99. So question mark and 99, they have a relationship. I could use 50 and 90, or I could use 70 and 126 as my second fraction in this proportion. It doesn't matter. it matters zero amount which one you choose. I'm going to do 50 and 90 only because, I don't know, because. Again, I went from small triangle to big triangle for both of these, question mark to 99, 50 to 90. That works. If you mix and match the direction you go, you've done it wrong. If I did question mark over 99 and then 90 over 50, you're going to get the wrong answer. There's like 12 ways to set this proportion up correctly. And if you do it backwards, that's the one way to do it wrong. So make sure you're consistent. Just do always left to right or always small to big. Pick a direction and stick with it. Okay, cross, multiply, and divide. So I'm going to do 50 times 99. If you are teaching this to students who are seeing proportions for the first time, I highly recommend, after you've established this is the way I'm going to do it, this is the way I'm going to do it, then start showing different ways. Say, I'm going to do it differently this time. Let's see if we get the same answer. Because then you can kind of represent, oh, look, yep, there are other ways of doing the same problem. You get the same answer. You pick your favorite. All right, I found the answer. It's 55, which feels right. This side, 99, is bigger than 90. So this side should be bigger than 50. It is. This side is the biggest, 126. 70 is bigger than 55. Yep. So that seems to fit. I'm going to give one more a try. So again, pause it. Try this one on your own. Excuse me. All right, here we go. I'm not going to redraw the original because I've got it side by side here. Again, please do pause it. Don't just watch me. That's boring. Do it on your own. Give it a try. I'm going to redraw the two triangles separately. You do not have to do this. There are other ways to find the solution. I'm going to fill in what I know. I know that this side is 22. This side is 77. So there's a relationship right there. I know that the whole bottom, FH, is 42. I know FG, that side there on the left, is 84. Looking at the small triangle, though, I'm not given any other numbers. I don't know FR. I don't know FS. I could figure out FR, though. If from R to H is 30, and from F to H is 42, this part here has got to be 12, because 12 plus 30 is 42. I know the picture doesn't look like it, but based on the numbers we were given, this is the only option for FR. FR has to be 12 if RH is 30 and the whole thing is 42, because 12 plus 30 is 42. And then the question mark isn't FS, it's SG. It's like this little chunk right there. That's where the question mark is. And that doesn't show up on my small triangle. However, just like how I could figure out what 12 was by knowing this little piece here and knowing the whole thing, I'm going to do the same thing to figure out the question mark. So I'm going to label this, instead of question mark, I'll label it, I don't know, lightning bolt. You can label it X or S or V or whatever you want. I'm going to use lightning bolt because it's fun. Okay, so I'm trying to solve for lightning bolt. And then once I know what lightning bolt is, I can figure out what question mark is. All right, there's a relationship here, 12 over 42. That relationship has to be the same as lightning bolt and 84. Remember, 84 is the whole length, not just this part. So lightning bolt over 84. If you did it a different way, you may still have the right answer. So don't erase anything. I'm going to cross multiply. And I'm going to divide. And I'm going to get that lightning bolt is 24. This part right here, that chunk is 24. Okay, so I know from this line down, from S to F, that piece right there, is 24. So from there, there's 24. If the whole thing is 84, and this part right there is 24, that question mark, that remaining piece, has got to be 60. And I know it doesn't look like it, but that's the way the numbers work out. So that question mark piece has to be 60. Again, if I know that the whole thing is 84, and I figured out that this piece right there is 24, the remainder, what's left, question mark, is going to have to be 60. So yes, you may have to do some kind of working your way through these problems. They're not always straightforward, but that's an example of what you do if the question mark, if the x, the variable, whatever you're looking for, is not an entire length of the triangle. I have some suggested problems. These are listed in D2L as well out of the book. You can probably search for similar triangle problems online too, but these are some good ones out of the textbook on page 791. We are not going to do this activity. Sadly, it's one of my favorites about Shack. We were going to do some construction and some cutting and building, but we're not. You don't need to know mid-segments. We were going to talk about Pixar and how Pixar uses mid-segments to do their animation, but we're not going to look at that because we don't have time. Next week, after the test, you will need some kind of a tablet, a laptop, a smartphone. Laptops are going to be the best. A tablet will work, and a smartphone will work less well. So if you have a laptop, access to a laptop, please bring one. If you have a tablet, that will work just fine. If you have a smartphone and nothing else, bring it. You can still do the activity. It'll just be a little less fun. Okay, that's it for this video, and I will see some of you on Thursday, and I will talk to some of you on Thursday, read your email, and I will see you next Thursday on the 2nd.